Hello everyone, we are back again taking another exercise of 10.1. the exercise number is 3 and the statement is two chords AB and AC of a circle make equal angles with the radius through A. Prove that AB is equal to AC. Well, I have written a little bit already here to reduce the length of the video. Here the statement has asked for two chords AB and AC, AB and AC, and also a radius through A. Well, I have taken two chords. One is AB, another is AC, and I have also taken a radius that goes through A. I have also taken a radius that goes through A. That one is radius goes through A. See, going through the A. But the statement has given a hints it has given something so that we can prove that AB is equal AC, and that is the two chords AB and AC of a circle make equal angles with the radius through A. Two chords AB and AC of a circle, chords AB and chord AC make equal angles with the radius through A. Okay, first look at this chord AB. This chord AB makes an angle with the radius OA. This chord AB makes an angle with the radius OA, and the second chord AC also makes an angle with the radius OA, and the angles are same, and both angles are same. See, two chords AB and AC of a circle make equal angles. They have said that this angle is equal to this angle, this angle is equal to this angle. Okay, explanation of the diagram is on your screen. Let ABC be a circle with the center O. AB and AC be two chords. AB and AC be two chords. OA is the radius of the circle. We have to prove that AB, chord AB is equal to chord AC. We have to prove that AB is equal to AC when angle BOA, this angle BAO is equal to angle CAO. This one is given by the statement. Following this, we have to prove that AB is equal to AC. To prove this, we have to draw two perpendicular. To prove this statement, we have to draw two perpendicular. One is from both of the perpendicular have to draw from O, from the center. So I have drawn a perpendicular from the center O to AC. This one is perpendicular to OM is perpendicular to AC, and I have drawn another perpendicular ON to AB. That means ON is perpendicular to AB. So this angle is equal to 90 degree. and this angle is also 90 degree. Well, I have said that proof. In proof, we have drawn two perpendiculars from O to AC and AB so that ON is perpendicular to AB and OM is perpendicular to AC. By drawing the two perpendiculars, we have found two triangles. We have found two triangles within the circle. One is this one, A and O. One is this one, and another is AON. Another is this one. By drawing these two perpendicular, we have found two triangles. One is triangle ANO. Another triangle is AMO. If we compare these two triangles, if we try to compare these two triangles, we can say that we'll find that. So we are going to compare these two triangles in triangle ANO and triangle AMO, triangle ANO and triangle AMO. This angle is equal to this angle. This is given by the statement. This angle is equal to this angle. Angle NAO and AO is equal to angle MAO. MAO. This one is given by the statement. So we are writing in the parenthesis given. And see, this angle is equal to 90 degree in this triangle, and this angle is also 90 degree in this triangle. See, this one is 90 degree, this one is also 90 degree. So we can say this angle is equal to this angle. That means angle ANO is equal to angle AMO. Angle ANO is equal to angle AMO is equal to 90 degree. And if you see carefully, you will notice one thing, that there is a common side both in this triangle and this triangle. This side is also in this triangle and also in this triangle. So you can say that side OA is equal to side OA. Within bracket we can write common side. So there is a theorem in class 7 book that if two triangles and one side of a triangle is equal to two angles and one side of another triangle, we can say that the two triangles are in congruence. If two angles and one side of a triangle is equal to two angles and one side of another triangle, then the two triangles are congruent to each other. If two angles and one side of a triangle is equal to two angles and one side of another triangle, then the two triangles are congruent to each other. See, in these two triangle ANO and triangle AMO, this angle is equal to this angle and this angle is equal to this angle. So we have found two angles of triangle that's equal to another two triangles of another triangle, and there is also one side that equal in both triangles. So we can say that this triangle is congruent to this triangle. So you can say triangle ANO is congruent to triangle AMO. So you can say triangle ANO is congruent to triangle AMO. What does congruence means? Congruence means when two triangles are congruent to each other, three sides of a triangle is equal to the three sides of another triangle. Since these two triangles are congruent to each other, then each side of this triangle is equal to each side of this triangle. So you can say this angle, we have already shown that this angle is equal angle OA and OA common side, and we'll left another two sides, this one. We can say this side is equal to this side. We can say this side AN is equal to this side AM, and OM is equal to ON. Why? Since these two triangles are congruent to each other, so each side of this triangle is equal to each side of this triangle. We have already proved that triangle ANO is congruent to triangle AMO. So we can say this side of this triangle is equal to this side of this triangle. So you can write, so side AN is equal to side AM. Side AN is equal to side AM. Well, this was our diagram. What we have proved, AN, side AN of this triangle is equal to side AM of this triangle. Now we can write, or instead of AN we can write half of AB. Instead of AN we can write half AB, and on the right side we can write half AC instead of AM. We can write half AC instead of AM. How can we write this? A question may arise. See, if you remember the first theorem of the circle, if we draw a perpendicular from the center to the chord of a circle, the perpendicular divides the chord into two equal parts. if, according to first theorem, if we draw a perpendicular from O to a chord AB or AC, that perpendicular divides that chord AB or AC into two equal parts. So we drew this perpendicular from O to AB. This one is 90 degrees. So we can easily say that this perpendicular has divided this chord into two equal parts. So we can say AN is equal to BN. AN is equal to BN. AN is equal to BN. So total chord is AB. Total chord is AB, and I can write AB in this way: AN plus BN. AN plus BN. Now see, AN is equal to BN. AN is equal to BN. So I can write AN instead of BN. I can write AN instead of BN. So AN plus AN is equal to 2AN. AN is equal to AN plus AN is equal to 2AN. So AB is equal to 2AN. AB is equal to 2AN. So AN is equal to half AB. AN is equal to half AB. Similarly, we can say AM is equal to half AC. AN is equal to half AC. AM is equal to half of AC. I have written these two information here: half AB instead of AN and half AC instead of AN. So if we multiply the both sides by 2, these two cancel each other. These two cancels each other. So AB is equal to AC, and we have proved the statement. Thus proved. Hope you have understood the whole process. If not, contact with me. I will explain again for your better understand. For today, we are leaving, and we will see you in next class taking another exercise of 10.1. Till then, goodbye.